Push that rock with Simpson math. So in math, we come across these special numbers like pi, which is defined to be the circumference of a circle divided by the diameter, and e, which is defined to be the limit as n goes to infinity of 1 plus 1 over n raised to the n. And these numbers cannot be written as a ratio of integers. That makes them irrational, because there are no two integers that you can make a fraction with to get the exact value of pi or e. And in this video, we're going to learn about another such number, and the symbol for it is fun. It's the lowercase phi. This letter is also, this Greek letter, this is the lowercase version of it, is used to represent the number we're going to talk about today, called the golden ratio. And I said phi, but it can also be pronounced phi, and so I think that's fun because of the English poem, phi, phi, fo, fum, something like that. I smell the blood of an Englishman. But anyway, so phi or phi, lowercase letter, represents a golden ratio. What is a golden ratio? It's another irrational number that's famous in math, and I need you to know about it. So you take a segment, any segment, and we are going to label this A and C just so we'll have some labels. But you take a segment, if you cut it in such a way that you create this special ratio and special proportion, then you can create the golden ratio. So what is the golden ratio? Well, first I need to label this. So the golden ratio is, well, there's a bunch of terms here, so let me slow down. Let's go with golden section, and then go up to divine proportion. And some books treat all of these as synonyms. I'm going to create a slight nuance difference between each one, but they're basically synonyms. And then golden ratio. And sometimes all these phrases are used to mean the same thing, but I'm going to call it a golden section is the section that you create when you cut this segment in such a way that you create the divine proportion. What is the divine proportion? Well, the divine proportion is when you take the whole length, that's AC. This symbol just means the segment AC. So the segment AC, and you divide it by the segment AB. If that equals the longer segment AB divided by the shorter segment BC, then this is the divine proportion. And since these are equal, either one of these ratios, that one or this one, is the golden ratio. Wow, that was a lot. So you cut it in such a way that the whole segment ratio with the longer segment, if that equals the longer segment ratioed with the shorter segment, then you have the divine proportion, and either one of those ratios is the golden ratio. Okay, so what is the golden ratio? Well, let's find out. Let's take a segment, and let's say it's 1 unit long. Okay, and let's cut it somewhere at X, and let's say we're cutting it so that we have the golden section. That means that this whole thing, which is 1, is to the longer segment, which is X. We're going to say that I cut it at X creates the longer segment, as this longer segment X. So if this is 1 unit long, then from here to here is X units long. So 1 is to X as X is to, well, what's this length here? Well, if this length is X and the total length is 1, this is 1 minus X. So this will be 1 minus X. Now we can solve for X. How easy is that? Cross multiply, we get 1 minus X is equal to X squared. Set it equal to 0, so add the X over, subtract the 1. I have an A is 1, a B is 1, and a C is a negative 1, and I do the quadratic formula. X equals negative B plus or minus the square root B squared minus 4AC. What's A? 1. C is a negative 1. All over, that messed up the whole song, didn't it? All over 2A. I can't carry a tune anyway, so stop singing now and stop torturing you. So let's see, what do we have here? We have a double negative, so we have 1 plus 4, so we get 5 on it. So we have negative 1 plus or minus the square root of 5 over 2. Now, one of these is clearly negative. Negative 1, back up 5 is negative. Well, we defined it, this being a 1, and we went in a positive. We're going to say it's x. So our x is the positive 1, which would be negative 1 plus the square root of 5 over 2. Because the square root of 5 is slightly bigger than 2. Take away 1, you're still slightly bigger than 1. Divided by 2, you're positive. But negative 1, take away a number, that would be negative. So we throw out the negative 1. So there's is our x. Now, x is not, this is not the golden ratio. We haven't found the golden ratio. All we did was find the distance to here. You might say that's the golden section, I guess. But the golden ratio, what is it? Well, it's 1 over x. Oh, so I need 1 over our x, which was negative 1 plus the square root of 5 over 2. Now, I'm going to realize that that just means I have 2 over negative 1 plus the square root of 5, or 2 over the square root of 5 minus 1, because this 1 over means you just reciprocate. Now I'm going to multiply by this conjugate of the denominator in order to rationalize, because right now it's kind of ugly. Okay, so I get in the numerator I have 2 times the square root of 5 plus 1, but down here I get this squared, which is 5, minus this squared, which is 1. So I have 2 times the square root of 5 plus 1 over 4. And we can reduce, and so we get phi, which is the symbol for the golden ratio, is the square root of 5 plus 1 over 2. Now, what is that about? Okay, so phi, or phi, another correct pronunciation is to say phi, is this value right here. So what is it approximately? Well, the square root of 5 is slightly bigger than 2. You know, I don't know what it is, but it's a little bit bigger than 2. Maybe we need to know what it is. I don't know. Try to estimate. And if I come out with the right, I know what this is supposed to be down here. So, you know, if I don't get it right, well, then this is what it should have been. But let's say it's about 2.2 plus 1 over 2. So I get about 3.2 over 2. And sure enough, 2 goes into 3.2. That's about 1.6. So the calculator will spit out this, I do believe. So if you need it, you'll never, in my class, you'll never need the accuracy out to the thousandths place. It's about 1.6, okay? Math made simple, Simpson math.